the new address of the Amazon Web Services deployment version. Let's log in here. So here you create a new project. Let's say 5 dummy. Please don't put a space in here, no space. So I'm assuming you've seen all the other tutorials, so you know how to use the rest. So the main difference is if you go to advanced coefficients, this is more advanced coefficients, there is one additional option here: climatic model original versus revised. Original one is the one originally proposed by Dempsey, and revised one is essentially there are a few revisions that are going to be described in the documentation. It's essentially the effect of cloud cover on the shortwave radiation is revised. Essentially, it's supposed to be more accurate. So you can click this one to the revised model and click save. You will see that. Other revisions is the standard deviation equations are placed here. So these are for the reliability calculations, or this distress, it's a reliability calculation. So these are the equations for each of the distresses. You can modify them, these coefficients, but you need to make sure that you use the same kind of terminology. For exponential, you use exp. For log 10, you use log 10. For bottom-up cracking, you use just bottom. So just don't change these parameters, but you can change the equation, you can change the coefficients. So, and if you go to analyze, let's just put a large number here. So I'm not going to analyze it because analysis takes some time, so I'm going to open in one that I already analyzed just a moment ago. So here there's a little bit of a difference also, more features added here. So when you click plot distresses, it's going to just plot the distresses that was run last time. Remember, these are at 50% reliability. So if you click tabulate, this is new, tabulate distresses, it will just tabulate all the distresses that are plotted there. You can just take copy entire table by just clicking here. So you can open an Excel sheet, say, and then paste, and you will get all the data in an Excel sheet. So another feature is these two are the same as the before, just the titles have changed. So you can download the PDF report and download input-output data. So another feature is apply reliability. So this is the table that shows the reliability percentages. 90% reliability is here. So if you click evaluate, and then it will calculate them, it will show the distresses at 50% reliability, which was in the same table as this one, and also it will show the distresses at the specified reliability. So if you change it to 80% reliability, let's say, some of them, if you click save, if you evaluate again, then without rerunning the whole thing, so you'll see the distresses at the desired reliability levels. So another thing that I want to show is if you download the input-output data, if you click yes, so it will download here, open, you will see this is like a temporary name. So under the folder, you can just rename whatever the project name you had. Under the folder, if you go to climate in-out subfolder, here there's this additional radiation data that is output. So this has two text files. One of them describes the column names, so like QROD, QS, QA, QE, QX, and RHR. These are the column names, and this is the actual data for each column. So you can just open this in an Excel sheet, and you can see this is a big file, and this is hourly radiation for every single hour. This is that are used in the simulation. So if you have 20-year simulation, so it's going to show you the hourly radiation values that are computed for every single hour. So now you can use and plot this data in can see the radiation value. So what are these data columns? If you look at QRAD QS, you can just go help and go to documentation. In here, if you go to page, let's say, right, the page 15, 16 or so. So the page 28, you can see here. Okay, let's see. Okay, so these are the values. QRAD in that column here, like the first column right there, corresponds to net radiation flux influenced heat transfer at the surface. That's what this is, and these are all different parameters. And also, where's this R value? Let's see. Calculate the hourly R value that goes into this, which is this value, RH, for each hour, which is the solar radiation at any time, and that is essentially this, basically this shape that's shown in here, the equation. Assume the equation is shown here. So that is going to be the column, last column right here. Underscore ENG is the engineering, not engineering, English unit. So, right, I think that's it.